Electronics and Electrics. What you've come to is a webinar on the testing procedure for arc quencher systems. I'm going to go over a couple housekeeping items. One is you've called into a go-to webinar, so your phones are muted if you're an attendee, but we'd love for you to interact and ask questions. And there is a question box to the right side of your screen where you can ask questions or chat. There's also a part of your screen to the right that includes some handouts. So there are 4 or 5 documents there for your download pleasure, such as an arc flash mitigation toolbox, and a guide spec for a medium voltage arc quencher, and brochures on the AQ 1000 and 2000 arc quencher. None of those are really going to be discussed today, but we just thought we would put them there for your reference. So please ask questions. One thing that's special about today's webinar is we're going to be playing a video, and the video may pop up in a separate screen than the screen you see the presentation on. So if you can't see the video, just let us know in the question box, and we'll try to help you. It might be a good idea to, when the video starts, minimize all of your other windows. Sometimes the video actually pops up kind of behind the GoToWebinar presentation screen. So with that, I'm going to hand it off to Mike Bukovitz of Tech4.
Well, good afternoon, everyone. We consider it a privilege to be able to present to you today. And if you have any questions, please forward those in the chat screen, as Michael mentioned. Before we launch in today, I just want to add that the testing procedures that we are communicating today are unique to our system with respect to our arc quencher, our ArcTech arc quencher system is the only UL listed resettable arc quencher system currently on the North American market, to the best of our knowledge. And the resettable nature of this arc quencher solution is valuable for 2 reasons. One, if you ever have an arc flash event and you're in any type of critical power application, and the ability to get your system rapidly back online once you remediate the cause of the fault event could be important to the operation. So that's the first reason why resettability is important. And the second reason why arc quencher resettability is important is because like any electromechanical device, such as a circuit breaker, the clearing time, or in this case, the closing time of the arc quencher device should be periodically validated. And of course, as Vivek will cover in the upcoming presentation, we recommend that the arc quencher systems be maintained at the same frequency that the facility or plant maintains their circuit breaker devices, either following NFPA 70B guidelines or factory mutual maintenance recommendations. A typical testing frequency in a normal environment for a circuit breaker would be once every 3 years, and if that's the policy you follow, then we recommend you test the quencher system, as Vivek is about to detail, once every 3 years. So the ability to validate periodically by testing, as well as return the facility rapidly to normal operation, are the 2 most compelling reasons why resettable arc quenchers are valuable in any critical power application. So without any further ado, I would like to introduce Vivek Saurabh, who's one of our staff power system engineers at Tech4, who has specialized in both ground fault detection as well as arc quencher systems and arc flash mitigation, and he has put together, and it's if there's a couple of rough spots here, this is we put this together last week, and this is our very first presentation on how to test an arc quencher system. Vivek, you have the floor.
Thank you, Bucky. Hi, everyone. Good afternoon. I hope all of you are well and safe during the ongoing pandemic, and I wish your families all well and safe. So to start off the presentation, I'll be giving you a presentation on testing procedure for an arc quencher system. So let's start. So the Tech4 arc flash mitigation system, consists of two main sections. One is the arc flash detection, and the other is the arc quenching. The arc flash detection is done through the arc flash protection relay. It's pretty much the brain of the the arc flash mitigation system. It senses light plus current and sends a trip signal to the arc quencher AQ1000 device, which I'll be showing in the next slide. So all of this process happens under 4 milliseconds. The sensor relays itself, the AQ101, they are just light detection, and they can be placed up to, I think, 3,000 feet as the distance in a different building where you want to still protect your downstream assets and downstream equipment. It shares the light back to the AQ110, and it also sees the current, so it sends a trip signal to the AQ1000 arc quenching device, and it quenches. And all of this takes place in less than 4 milliseconds. And let me go to the quencher slide to explain more about that next. So that's the AQ1000 low voltage arc quencher device. So the arc quencher, when receives a trip signal from the AQ110, creates a low impedance path. It shorts all the 3 phases, and due to which there's a collapsing of the voltage, which extinguishes the arc, and the upstream breaker can trip, for the short circuit. So that's the AQ1000 device, and like Bucky said, it's the resettable. It's the only resettable arc quencher device in the market. So this is just a slide of what the arc quenching definition is. The system can reduce the arcing or extinguish the arc by creating a low impedance path. And in this case, in our system, it shorts all the 3 phases, and the collapsing of the voltage extinguishes the arc. So a little bit about the Tech4 AQ1000 device. It's a patented Thomson coil-based system. It's the only reusable device in the market. There's a mechanical life of 100 operations, but it's limited to 4 operations on load, or for 65 kA, and 2 operations at 100 kA. There's also a medium voltage arc quencher. The clearing time of that is less than 6 milliseconds. But let's just concentrate on the LV AQ1000 device in this slide. So here's just an application drawing of an example of a main system of how the Tech4 arc quencher system looks like. So that's the AQ1000 device, which receives a trip signal from the AQ110 arc flash protection relay. So when it senses light, which is a flash, and one of the point light sensors picks it up, and it simultaneously detects a high current, it sends a trip signal to the arc quencher device, and all of the process again takes place between, less than 4 milliseconds. Let's talk about the testing procedure, which is the main topic for today's presentation. Anyone has any questions, please stop me to ask. I'll be happy to entertain all sorts of questions. So the testing procedure. So at Tech4, we perform a factory acceptance test and a site acceptance test for the arc quencher system to ensure the quencher is working properly with the AQ110 relay detecting light and current. And also an important thing we do is measure the quenching time. make sure it is under 4 milliseconds. Also, like Mike Bukowicz was explaining that, it's a life safety device, and it's better to periodically test the arc quencher, and you test your circuit breakers as well. So for testing the arc quencher system, we have to create an arc flash event, injecting a high current, and also probably use a camera flash in this case to for the flash. So a light plus current initiation would send a trip signal from the protection relay to the quencher, and the quencher quenches. So we at Tech4 use a universal relay set to inject current, like the Micron or the Doble, but we use a Panovo test kit, which is used to inject the high current, and also we use a sun pack or any camera flash, which can trigger a flash and pick up light from one of the sensors. So this is more about.
We have a question.
Yeah, I'm sorry. Let me look under the tab.
You might want to go back 2 slides just to clarify. Sam Patel is asking how many hits can the quencher take before you have to replace it, and I think you outlined that on second slide. So why don't you just do that one more time?
Yep. So it's 4 operations at 65 kiloamperes and 2 operations at 100 kiloamperes. Was that the
so
only
I think it's
number?
I'm gonna Vivek, I'm gonna jump in here for just a second. So whether it's 4 operations or 2 operations, resettability is important, but this is what's even more important, I think, for you to remember if you are an electrical plant engineer responsible for the system. Arc flash events in any single facility on any single circuit should be rare. Now, again, when we look nationwide, yes, we get, anywhere between 6 and 8 arc flash events per day. But in a single facility, and on a single circuit especially, okay, to have more than 1 arc flash event occur is absolutely indicative of either poor work practices or poor equipment condition, or both. So by the point I want to make is, in addition to the resettability specifications you see on the slide, is if in your facility you have more than 1 arc flash event on the same circuit, you probably won't have to worry about resetting the arc flash quencher even a second time. You're going to have to worry about getting your resume ready, because someone who owns that facility or is responsible for risk management and liability issues in that facility will be asking questions of why repeated persistent arc flash events are taking place. So while resettability is important, it should be noted that no arc quencher ever should have to be reset 2 times. After the first arc flash event, it's expected that you would take the appropriate steps to either remediate the electrical safe work practices in compliance with NFPA 70E, and or correct the equipment conditions that allowed such an event to take place. So go ahead, Vivek.
Yeah, I also see a question from Shyam. I think that was the same question about the arc quencher being resettable. Yeah, it's resettable after it takes the hit. After the quencher quenches once, after an arc flash event takes place, you can reset it, and it can be, can work for another. If an arc flash event happens again, quencher is again live and active.
But for testing purposes, you can test the arc quencher in terms of closure operation 100 times. So you're going to test it probably a couple times during initial commissioning, and then once every 3 years after that. So it'll last a long time with 100 test operations like that.
Yep. Also, ArcTech has built a commissioning mode, which is especially for for us testing the quencher before we install it in one of the plants. So you can test it up to 100 operations. It's a mechanical cycle life, 100 operations. So yep. let's go back to the presentation. So, yeah, so I was talking about injecting current and, using a camera flash to trigger the trip signal from the AQ110 relay to send it to the arc quencher. And, we measure the time. We measure the time on an oscilloscope to verify it's under 4 milliseconds. So, and again, I've explained here how the arc quencher receives a signal from the relay and it creates a low impedance path. It shorts the 3 phases, and by doing so, the voltage between the phases collapses and, extinguishes the arc. So here I explain a little bit more about how we measure the time on the oscilloscope. So what we do is while testing, while commissioning, while it's in the shop on our floor, we don't really have a bus bar to connect to all the 3 phases to create a short. So we apply voltage to one of the phases using the same relay test set. So we look that up on the oscilloscope. We use a probe so you can see the voltage, and we also use a probe to monitor the flash. So when the flash is triggered and the voltage collapses, we can verify the time and make sure it's less than 4 milliseconds. So that's how we do it. The voltage collapses when when the quencher goes off, and the time between the trigger of the flash and the voltage collapsing, we can measure the time and we can ensure that it is less than 4 milliseconds. So that was just a photo of the oscilloscope where what I was talking about. The yellow bar on it is the flash, and that's the flash trigger. And at the same time, if you see the blue, which is there was 5 volts applied to one of the phases of the quencher. So it took almost less than 3 milliseconds. I think one single grid or one single box was 1 millisecond. So it took up to 3 boxes for the quencher to go off and the voltage to collapse to 0. So this is how we test here at Tech4. So that was the presentation on how to test an arc quencher system. It's unique to the ArcTech AQ1000. We don't really need to have use an oscilloscope, but it's just since it's a life safety device, it is better to ensure the quenching time is less than 4 milliseconds. So that is it. And if you have any questions, I'm here to answer them. And
are you going to show the video?
Yeah.
No?
I was looking that up. There's a short video. I thought a video demonstration might be a better understanding to the viewer on how to test the arc quencher system. Can everyone view the video? Okay. Usually, like John said, it's a small window which pops up. If you can't see the video on your screen, try to minimize all the windows you have, and you should be able to see it. It says screenshot. That's what the name on the tab is. All right. I'm gonna go ahead and play the video. If anyone can't see it, please let me know. I'll pause it so we can fix that before going ahead. So, okay, playing the video. Hi, I'm Vivek, the power system engineer who just gave you a presentation on testing an arc quencher system. Here's a setup of the arc quencher system, and I thought a video demonstration would help the viewers understand it a little better. We have the entire setup here, including the ArcTech devices, such as the arc quencher AQ1000, the arc flash protection relay AQ110, and a point light sensor, which is used to detect flash or light in this case. Let me start explaining the arc quencher system. The setup we have here, this is the AQ1000. This is the point light sensor. This is what we're going to use to detect the flash. This is the AQ110 arc flash protection relay. It's pretty much the brain of the arc quencher system. It detects the light and current and sends a trip signal to the AQ1000. And all of this takes place under 5 milliseconds. we are using the Panovo test kit to inject current into this, and we're using a sun pack flash to demonstrate an arc flash. So when we run the state sequence as set up here, it's going to inject current into this relay, and this is going to flash, and it's going to send a trip signal, and the quencher is going to go off. We have used an oscilloscope here to measure time. We've used two probes. Probe 1 is put across the flash. It just shows you when the flash is triggered. And probe 2 is put across the voltage. We have induced the voltage on one of the phases on the quencher. How we have done that is, let me show you the back of the quencher. This is how it's mounted on the bus bars, the 3 phases, and in this setup right here, to demonstrate an actual, collapsing of the voltage, we have induced voltage on one of the phases, and when the quencher trips, we can see the voltage collapsing and measure the time in the oscilloscope. So I've set up a state sequence on my Panovo test software. It's a test kit like any other, like the Micron or the Doble. This is the current injection to the 110 relay. This is triggering the flash, and this is for the voltage, put across the back of the quencher. So what's going to happen here is when I run the state sequence, the Panovo test kit is going to inject current into the arc flash protection relay, and at the same time, the flash is going to be triggered. So when there's a light plus current input, the AQ110 relay is going to trip and send a trip signal to the quencher, and the quencher is going to go off. And all of this is going to happen under 5 milliseconds, and we can verify here with the oscilloscope. So let us go ahead and run the test. So that was the quencher going off. We can measure the time here using this oscilloscope to make sure if it was under 5 milliseconds. So as you see here, the yellow probe is for the flash, so it triggered at that particular second. And this was, the blue line is the voltage. So there was 5 volts of voltage across one of the phases. So when the flash is triggered, it took almost 3 boxes for the voltage to drop to 0. And each box is, the scale is each box is 1 millisecond. So according to this, the quencher went off in less than 3 milliseconds. So as we saw, we could measure the time on an oscilloscope and confirm that it was under 3 milliseconds. The tester, the Panovo test kit, also measures the time, but it includes a latency time, and it might not be accurate and might not be under less than 5 milliseconds. In this case, it was close to 7 milliseconds, but that includes the latency time, and that's not the exact time the quencher takes to quench. That is why we've used an oscilloscope to verify that it quenches under 5 milliseconds. One other thing about the ArcTech AQ1000 device is it's the only resettable arc quencher device in the market, and an arc quencher AQ1000 trips up to 4 times under load. But there is no way of knowing. There's no way the AQ1000 detects that you're testing it. So ArcTech has built in a commissioning mode, which helps us, which is used while testing. So the AQ1000 knows it's not under load and it's not in use, so it bypasses the trip count. So that was a demonstration of how to time test an arc quencher, and that's how we do here at Tech4. We don't really need to use an oscilloscope since ArcTech ensures us that quenches under 5 milliseconds. It's just to be extra sure that verify the time the quencher goes off is under 5 milliseconds. Thank you for viewing this video. If you have any more questions, please contact any one of us at Tech4. Thank you. So yeah, that was the video. I'm sorry, I heard the echo is bad, and yeah, to mute myself so everyone could hear better. Also, one thing I want to point out was I say it as 5 milliseconds in the video. Up until 2019, that was arc quencher device from ArcTech was under 5 milliseconds. Apparently, the newer versions of the model, it quenches under 4 milliseconds, and yeah, so that was just one thing I wanted to point out. One other thing I wanted to show for testing the arc quencher, it's just a connection drawing. Can everyone see my screen with the, okay. So that's just a connection drawing of how we set it up for testing the arc quencher. This is the Panovo 6, the Panovo relay tester is used to inject current to the AQ110 relay, and the camera flash is used to, the camera flash is used to flash the point light sensor. So the light and current, when it detects the light plus current, it sends a, trip signal to the quencher. What we see on the oscilloscope, channel 1 is for, we apply a voltage across one of the phases of the quencher. That's probe 1, which is measuring, the voltage across the phases. And probe 2 is when we trigger the flash. We trigger the flash using the tester itself. We set up a state sequence on the relay test software to inject current and flash at the same time simultaneously. So that's how that's done. So that was just a connection drawing I wanted to show for people who's more interested to time test the quencher. Our tech does ensure that it trips under 4 milliseconds, but since it's a safe, it's a life safety device, it's always better to ensure it's under 4 milliseconds. So we use an oscilloscope. We can also, the test set, the relay test set usually does measure the time, but it also adds up the latency time of the test kit itself. So in the video, you saw that I was talking about the test kit, measuring it at 7 milliseconds, but that was the latency time of the relay test set itself. So when you observed on the oscilloscope, it was under 3 milliseconds. So that's one other thing I wanted to point out. So if anyone has any other questions, I'd be happy to answer. I'll look up the question pan. Yeah, I think I just see the old questions about being resettable. What exactly does it mean? Someone has asked, does Siemens have an arc quencher? Oh, that's the answer, sorry.
If someone asked, does Siemens have an arc quencher? Yes, they do. Siemens has an arc quencher called SiQuench, S-I-Q-U-E-N-C-H. You can Google that. It's a medium voltage quencher. It's a very robust device. It's rated for 5 reset operations at full voltage. That device is not yet commercialized for sale in North America. And at present, according to the Siemens product managers, at least as of last week, when we were in contact with them, it is not for sale other than in Siemens NX Air IEC switchgear. So the answer is, if you have an application in Europe or in other parts of the world that accept or expect an IEC distribution equipment, Siemens new switchgear offers that solution. It's not available in retrofit solution. It's not available in other people's equipment. And most importantly, right now, it's not available in North America. Good question.
I did not know that. It's not available in North America. That was something new.
No, North America, we're still ANSI IEEE, land here. So you don't normally see pure IEC distribution equipment installed in the United States or Canada.
I do not see any more questions. I hope this presentation was useful for anyone who wants to test an arc quencher system.
Okay, so one of the questions says, all we hear is an echo.
I think that was the old message, if I'm not wrong.
Yeah, okay, so my experience, though, is on these go-to webinars, if you rely on your computer for the audio, it works well. When I tried to listen on my phone to your video, I could not understand any audio whatsoever. The audio was crystal clear on my computer, though.
Yeah, I did not realize I had to mute it. I thought it's going to take the feedback from the, from the speaker itself.
So, Vivek, what I will ask you to do is post the video on YouTube, send a link to Mr. McClellan that he could forward to all of the webinar attendees, if you would, please.
Yeah, I'll do that. Yeah. So yeah, I hope this was a useful presentation and you got a little understanding or information about testing an arc quencher system. If there are no more questions,
hey, we have a question here, Vivek, and it's a very good question. It's on the operation of the arc quencher system. And it reads, will the arc quencher trigger if someone opens the switchgear door and takes a picture of the cubicle or bus inside?
So no. So when I mean that we'll have to flash, we can flash using a camera flash, you have to be really close to the point light sensor. You have to literally be just, not even in less than an inch away from the point light sensor to actually pick up the light. I think it's based on the lux intensity of the point light sensor. And no, if you just click a picture, even with your camera, even with the DSLR camera, which has a flash, an external flash, it's not going to trigger the arc quencher. And again, the arc quencher only quenches if it receives both light and current. It's not light only. So it's light plus current. So if it receives a signal of both, and again, it's the AQ110 relay, which detects the light and current and sends a trip signal using a fiber optic cable to the quencher. So no, if you click a picture, you open up a switchgear and click a picture, no, that's not going to trigger the quencher. It needs a lot more light than that. And most of the times, even with a camera flash, we struggle to actually initiate the point light sensor because it does not pick it up. You have to be absolutely close to it, less than an inch away, to to flash the sensor. And that's how it picks up the light. So to answer the question,
this is not a light only.
Interject.
Sorry, this is not a light only trigger. I think that's the key point here, though, is that in order to assert, it must see both more than, we typically have our sensors calibrated for 50,000 lux. It must see more than 50,000 lux of light. An arc flash event, by the way, generates more than 1 million lux of light. So the sensor must see more than 50,000 lux of light, and the relay at the same time must see the overcurrent event. And those two events must occur concurrently for the relay to assert and tell the quencher to close.
Yep. I see another
good question.
Hey, Mike,
great question.
There's another question here.
Yeah, see them now.
A question reads, is there a way to take advantage of a protective relay that already has an arc detection system, say a SPL 751, I think they mean the 751A, or of course multi-lin 8 series, to trigger the electromechanical portion of the device?
No, the arc quencher, the ArcTech arc quencher system, does not rely on a relay output, either solid state or electromechanical, to assert the quencher. In order to obtain that rapid clearing time, which is, again, guaranteed worst case to be less than 4 milliseconds with the low voltage quencher and less than 6 milliseconds with the medium voltage quencher, you have to use it as a system. And that the ArcTech AQ110 relay has a fiber optic output. And it's that fiber optic cable, okay, that sends the assertion command to the arc quencher device. There is no relay input to it because the latency time associated with those relay contacts would lengthen the total clearing time. So the system is UL listed and tested between the ArcTech AQ110 relay, okay, and the arc quencher device with a direct fiber optic cable between them. It's not an electrical trip signal. It is a fiber optic assertion signal. I should further add that because someone asked earlier about the Siemens system. The Siemens SiQuench system, okay, as presently designed by Siemens, uses our ArcTech relay, okay, and identical to our Arc Quencher devices, the SiQuench device is asserted not with an electrical signal, but with that fiber optic signal, identical to our own Quencher technology. Okay. Now, Eaton also similar to Siemens, Eaton also brand labels for their low voltage Arc Quencher solution are the ArcTech relay, but the Eaton Quencher is not a resettable device.
Yep.
I have another question here. This is a great question. What effort will it take to retrofit this Arc Quencher into an existing switchgear with 4 breakers? Are the breakers needing to have LSIG or shunt trip capability?
The Arc Quencher, whether new or retrofit, can only be applied when there is an upstream overcurrent protection device. In other words, in this case, a circuit, always a circuit breaker that's trippable. So you cannot have a fuse be the upstream overcurrent protection, the only upstream overcurrent protection device for a Quencher. The Quencher can be applied in a secondary virtual main application. In fact, it's a rather ideal location to put it in the secondary ATC of a transformer. It's one of our most common applications. And then trip the primary device on the primary of the transformer. That works. In terms of retrofit applications, which are slightly more than half of all of our Arc Quencher applications, we look at we engineer a solution for each retrofit application, but the upstream breaker, if in the case of that's a low voltage breaker, must have a shunt trip, must be able to be equipped with a shunt trip, because we don't wait for the breaker to see the fault generated by the Quencher. I want to be clear, when the AQ110P asserts, it concurrently asserts via a fiber optic cable the Arc Quencher device, and then via a high-speed relay output tells the upstream breaker to open or clear the circuit. And those two events occur at the same time. So if you're looking at a timing sequence here of an arc flash event, let's say this is a low voltage arc flash event. In less than 4 milliseconds, that the Quencher device will quench, so from arc flash initiation to complete extinguish of the arc flash event will be less than 4 milliseconds. But then we're going to wait another 55 milliseconds to 60 milliseconds, depending on the speed of the shunt trip mechanism to open that low voltage circuit breaker. So great question. In terms of retrofitting into existing gear, there's 3 ways we do retrofits. Option 1 is we put it in the secondary, the arc quenching device in the secondary ATC, air termination compartment of a transformer. It's its most ideal location. The second place we would put it is into a prepared space in the switchgear, between the main breaker and the feeder breakers. Assuming there is no upstream device, again, that's trippable in the equipment, and other than that. And then the third way we do it is in a standalone enclosure where we either cable or bus in, to the bus of the existing switchgear. And remember, the same size Arc Quencher device is used anywhere from 600 amp systems to 6,000 amp systems. So the current isn't normally, it's not wired in series, it's wired in parallel on the single line diagram to the power distribution system. And by the way, we provide examples of one line diagrams and We've done many different arc quencher applications, both new and retrofit, and all of these type of configurations. So great question. Thank you.
Yep.
Any other questions, Michael?
Well,
That
I
is
see it.
all.
For some reason, I'm
You
not
guys
having-
should be, everyone who attended will receive a certificate by tomorrow, 5 p.m. If you do not receive a certificate that you could use to prove PDH or continuing education credit, please let us know.
Thank you. Hope it was informative.
Thank you.